Welcome to Math 154 videos. This video is going to cover the power rule, and so we're going to go ahead and take the derivative of this function y equals 4x to the 6th plus 5x cubed plus x squared plus x to the 1/2, which is actually the square root of x. We're just writing the square root as an exponent. So we're going to go ahead and take the derivative. So dy dx is going to be equal to the derivative of 4x to the 6th plus the derivative, oops, I left out an x there, plus the derivative of 5x cubed plus the derivative of x squared plus the derivative of x to the 1/2. And that's because when we're taking the derivative of stuff that's added together or subtracted, we can just distribute that derivative operator to each term. So our first one, the derivative of 4x to the 6th. Well, we're going to apply the power rule here. So nx to the n minus 1. So our n in this case is 6. So we'll make that our n. So 4 times n, which is 6, right, 6. 4 times 6, x, and then our n minus 1 is 5, so we have to put 5 up in the exponent. Now we're done with that term. Plus, now we have a 5x cubed, so we're going to take our x cubed, the 5 just stays there, and these constants just stay there because we could pull this 5 out in front of the derivative operator and that would still be okay. So these constants in the front, the coefficients, those just stay there. So our n is 3 in this case, so we multiply by n out front, so that's 5 times 3x. Our n minus 1 is 2, so we put that up in the exponent. Now for x squared, well, our n is 2, so we're going to multiply by n out front, so we get 2x. Then 2 minus 1 is 1, so our exponent is 1. Then for x to the 1/2, well, our n is 1/2, and 1/2 minus 1 is a negative 1/2. So out front we're going to multiply by a 1/2 because that was our n value, and then our n minus 1 is negative 1/2, so that's going to go up in the exponent. So now we're going to get all together 4 times 6, that's going to be a 24, x to the 5th, plus a 5 times 3, which is 15, x squared, then plus our 2x to the 1, which is just a 2x, and then we can write this as 1/2 x to the 1/2, which is actually x, well, the square root of x. So I'm writing it in the denominator here because that way we can get rid of this negative exponent, make it positive. So this is our dy dx. Alright, so here's our second example, and you'll notice this time we have a function that looks a lot more complicated. So the first thing we're going to do is note that the cubed root of x can actually be written as x to the 1/3 power. So we're going to write the cube root of x like that from now on, just because it looks a little bit nicer. And now we want to get this function into a form where we can use the power rule. So what we're going to do is we're going to actually break this up into 3 separate terms. So first we have ax to the 4th all over an x to the 1/3. Then we have plus a bx over x to the 1/3. Then we have plus a c, and that is also over x to the 1/3. Alright, so now we've got this in a little bit of a better form. Now we want to deal with these ax to the 4th over x to the 1/3 because we have an x in the numerator and the denominator. So really, what that is is we want to do x to the 4th divided by x to the 1/3. So when we look at this, we want to subtract the exponents. So when we get a 4 minus a 1/3, well, that really just turns into a 12 over 3 minus a 1 over 3, because our 4 is equivalent to 12 over 3. So then we're going to get 11 over 3. So we're going to rewrite this now, and we're going to write that as ax to the 11 over 3. Alright, and a, b, and c are just constants, so they're any number. A could be like 2 or 5 or something like that. You just got to think of it as a coefficient, okay, just a number. Now we're going to do the same thing with our bx over x to the 1/3. So now we have an x to the 1 over an x to the 1/3, so we're going to subtract 1/3 from the 1. So 1 minus a 1/3 is going to give us a 2/3. So we're going to get plus b x to the 2/3, then plus a c, and we can rewrite this c over x to the 1/3 as cx to the minus 1 over 3. So now all three of these terms look like something raised to a power, and we can apply the power rule. So now we're going to finally go ahead and take the derivative. So I'm going to do that down here, and I'm actually just going to box off this extra stuff that we did. That wasn't in taking the derivative, that was just to help us reorganize what we were doing. Alright, so our y prime. This first term, ax to the 11 over 3. So now this 11 over 3 is going to be treated as our n. Alright, so we're going to multiply that in front, so we get a times 11 over 3. So we can write that like 11 over 3, and I guess we'll write it like this, 11 over 3 times a. And then we have an x, and then our n minus 1, well, what is that? So 1 would be written as 3 over 3. So 11 over 3 minus a 3 over 3, because 3 over 3 is 1, is going to be an 8 over a 3. So now we're going to put that up top in our exponent, because that is our n minus 1. Alright, now we're going to add to this our derivative of b, so, or bx to the 2/3. So this 2/3 is now going to be our n. So we're going to multiply that in front, so we'll get a 2/3 times b. So we can write that as a 2b over 3, right? 2/3 times a b over 1 is just 2b over 3. And then we're going to write our x. Now, 2/3 minus a 1. So what is that? Well, 2/3 minus a 1, which is a 3 over 3. What are we going to get? 2 minus 3. That's a negative 1. And then over 3. So that is our n minus 1. Right, so this was our n minus 1. So was this for our last problem, n minus 1. Alright, so we'll get a minus 1 over 3. And then our cx to the negative 1/3, we'll apply the power rule again with our n equal to a negative 1/3. So we're going to multiply that out in front. So we'll get a negative 1 over 3 times a c. Alright, and then we're going to get, in the exponent up there, we're going to want to do first our negative 1 over 3 minus a 1, which is a 3 over 3, so that's going to be a negative 4 over 3. So we're going to negative 4 over our 3 up there. Alright, so if we want, we can write that probably a little bit, that's y, just y prime for our derivative, right? So y prime is the same as dy dx, so we can write it like that. So we get 11 a over 3 x to the 8 over 3 plus 2b over 3 x to the negative 1 over 3. Then we have a minus a c over a 3, and then an x to the negative 4 over 3. So there's our derivative with the power rule. Now it might depend on your professor whether they want you to take the negative exponents and write them in the denominator, so you'll want to double check with them to see if it's okay to leave those negative exponents up there, and if it's not, we could just write those in the denominator. So that's our derivative.